Hello, Zdravite. Аз се казвам Rohit. Uh, аз живот младо в 4, not that you need to know. Uh, аз говоря малко български, so I just wanted to say a few lines because I tried to learn them a bit hard. But anyway, so I've been in the performance area for about 6-7 years now, and I would like to share my experience about what are some do's and don'ts. So let's get started. Yeah, I love this guy. He's trying his best, doing all he can, trying to achieve the goals. And the goals would, in this case, be to have a well-performing and high resilient system, which is something that we miss quite often. So I just want to share why we miss that. So the first thing is, of course, we are not having the real world scenarios, meaning we have a lot of tests. We put in a lot of effort to design and develop those tests, but they are nowhere what is going to happen in the real world. And why is that? Because uh, we don't touch base with the customer as often as we should. We don't talk to them, we don't explore the use cases as often as we should. And even before talking about the real world scenarios, I want to say that we need to find if a system actually deserves performance, because sometimes we test a use case or a system which doesn't actually deserve performance test, and that's your failing point number one. Uh, and let's say this is a system. You're given a task to test it. Is it something that you really want to do? Like, do you really want to do a load test on a system that looks like this or this? I don't think so. I mean, even if you try to see how much data can flow through the system, it's useless because I mean, if you can tell from the first glance that the system is not going to scale, I think that's it. We should tell, that should be our first point of feedback, and sometimes we miss that. We just try to test even before we know if the testing is required. And performance testing has a lot of cost. It has a lot of cost of execution, maintenance, and development. So why would you spend money and effort on something that's not needed? The next, like, this is an example of a like, I would like to ask you, do you think this is a test that should be done on a phone? Like, any yeses? Is this a needed test? Like, you try to put it on under the car? I mean, it's still debatable, but I still think it's a bit of an overkill, and it's not a real world use case. I saw some tests with a phone where they are trying to actually replicate your bottom sitting on the phone rather than the car tire, because the use case is different. It might bend, it may not break, crack, but the actual test should look like real use cases. So, of course. The next one, this one. Do you think this is real world? Like, sometimes we go too deep into trying to make sure this is a our product is the best. But do you really need a test like this, where you are trying to burn down your phone in lava? I don't think so. Another problem that we have is when people say get set go, we try and have as many tests automated as possible, and that's not always the right answer. I mean, there is a point after which you are actually losing value when you have too many tests to maintain. I mean, be it end-to-end or be it performance, it doesn't matter. And actually for performance, you actually lose that value much faster. So, I mean, the best way to measure value for performance is not just by the count of the test, but actually the aspects that you are covering. So are you covering the performance? Are you covering the resilience? Like, are you trying to make sure that you have many different facets covered and not just the number? I mean, running behind the numbers is not what we should be doing. And this is a graph that I have shown. So if you like, for every project there is amount of testing that is beneficial, and after which it is actually a negative impact on you. So the total number of tests that you have, there is going to be a point up until which you're going to be getting value, after which you just have some tests that are actually not giving you any value and actually are reducing the overall gains that you have from the testing framework. So another thing that people fall into, running behind the number of tests. Another problem with performance testing is that when you have tests that run 2 hours, 3 hours, 6 hours, endurance tests, and you leave a step in them that is not fully automated, So you have a step, you have to go and download some kind of a report at the end of the test from the environment. I mean, not everyone does that, but still some people fall into that, and that kills productivity like anything, like that kills productivity much more than anything else. And if you have such a step, get rid of it immediately. So I just told you what half automation is. You have an environment which you are trying to from which you are trying to download a report at the end of the test, or you are trying to get a snapshot of a failure, so something went out of memory, and you actually have to go in and take a a heap dump of the process that you have. If you have such a step automated, it's going to make your life easier. If you don't, then you will have to spend many hours looking into the right time when you need such a snapshot. And that's what's going to happen if you don't have full automation. You will be the only one in the city awake at 3 a.m. waiting for the test to finish. I told you how to avoid it. Automate everything and don't leave anything when you are automating. Some companies and structures have a way of doing that, meaning you will actually have an environment. You automatically work in AWS, and everything is there. So at the end of the test, you are pushed to do it. But let's say you have some servers that are yours forever. You have a on-prem environment, and they are yours forever. So what you're going to actually do is forget about cleaning and taking a snapshot or rerunning those steps. And you may have a step at somewhere in your cycle that is not automated. The next pitfall is you like test results that cannot be repeated, meaning you have a set of tests that you have automated very hard, but when you try to run them 6 months after, you cannot repeat them. Again, in one of my previous companies, previous projects that I worked with, there was a project with Oracle database that some database administrator came in and he just automated and did some tuning that nobody knows what he did. And after that, we had very good performance. And after a few weeks of that, we like the database administrator was not in the company, and somebody deleted the database, and nobody ever was able to bring back that performance. So the magic was gone. So always like take a snapshot of everything that you have done, because performance testing is much more complex than any other testing. And whatever you do should be committed in your repository and infrastructure as code. And these tools that I have mentioned here, they are really useful for such automation. Okay, so this is another thing. So what would you do if you have a magic wand, like Harry Potter here? Like you're excited, and like it would be stupid if you do this. Like you submit it, and you would say that, okay, I'm done. I just used it. I don't want to use it anymore. That's what we do sometimes with our tests. We automate a lot of tests, and we never put it in continuous execution. So you don't get to get the value of Harry Potter having those 7 more films and Voldemort being killed, because you just used it once on the day one, and then you said, I don't want to use it. So once you have a test, once you have put in a lot of effort, always make use of continuous execution to see the trends in performance. Because with performance, we cannot see trends unless we have a history of them. Because with just a few tests, you will never know if 2% degradation has happened in your release. So a large history of having exact X amount of performance or X throughput or X response times, and then suddenly you see a 2% degradation, that is something that you want to see. So a history is much more important in performance, and it should be always looked at. And the power is infinite. Like you have one release, you just tested your one release. You want to test all other releases after that. You have put in hard hours and hard amount of money into building that test, making that stable. So you definitely want to have and use it for the rest of the work, for all the future work basically. And then you will be able to slay Voldemort. So most of the time when we think about performance, this comes to mind, like how fast the things are. But is it really the case? Like non-functional testing, non-functional QA, they need not only look into performance, but also into resilience of the system. So, I mean, I'm going to say a few more things that I think we should be doing, and not just what we are doing. Fast is not always enough. So there are many non-functional aspects, and we should not just focus on performance all the time. What about the resilience? So tell me about this, like an aircraft landing on a landing strip. Do you really care how fast it lands, or do you really care if it lands or not? Like if it crashes or if it doesn't, or the weather is not right. So in this case, in some use cases, performance is like the second priority actually. It's the resilience which is much more important. And resilience is something that we always overlook in many projects, like because performance is such a buzzword, we always forget about resilience. The second thing, like if you don't test and think about all the scenarios, you remember this incident from Suez Canal when Evergreen was stuck. I'm not saying like the ship was not built and tested, but at least something went wrong. Like the whole entire end-to-end flow of getting that ship through the canal did not work. And there was a reason behind it, because at least something was not thought about. Maybe it was the pilots who were guiding the ship, or the helpers who were trying to tell them how to guide the ship to the Suez Canal. And that's when you should test a system in its entirety, not just the components, but integration with like human aspects and integration with many different aspects becomes much more important. And the last thing is something I learned from a very wise person in my previous experience. Like sometimes effectiveness comes, actually all the time, effectiveness comes before efficiency. So before you can actually go for being much more efficient and fast, it's much more important to be effective, to actually achieve what you're doing, which is the case of landing the airplane and getting the ship past the Suez Canal. If it was slower, not really that big of a problem if it just cannot pass through the canal. And what other aspects in resilience do we have? So I love airplanes and the way they work. So you see an airplane is certified to play, most of the airplanes, I believe, are certified to fly with just one engine if the second one is gone. But who certifies them? It's the engineers, like the people who look after the resilience. It cannot be just assumed that one day this is going to happen in the air and it's just going to continue flying like that. So it happens all the time. Like when the systems or its components fail, what does it happen? Those kind of tests should happen and should not be overlooked in any large environment, like large environment worth its salt. Okay, so what lies beyond benchmarks? When we are doing performance, we focus a lot of time on benchmarks. This is where we start. We measure how fast the things are, what is the throughput, what is the response time, what CPU we are using, but there is much more beyond that, like in the galaxy far, far away, a lot of things that happen. And some of the things that I mentioned, that we should always try and include them in our plans when we are working on them, like stress your system, go 2 times, 5 times, 10 times, like whatever your need be for the stress, run it for a longer duration. If you're running a 1-hour test, try and run it for 3 days, 4 days. See what happens, what kind of leaks you have in the system. See if you have a memory leak, file handler leak, or anything that the system is using up but is not freeing up will show up only after a long duration of testing. Like in one of the very early projects that I worked upon, the developers were amazed when we just wrote a shell script that did a request for 3 hours and the whole system crashed. So it's not something they could not have done, but it's something they did not do because they overlooked the fact that such a thing can happen. What is failover? So you just saw an airplane engine going down. So when an engine goes down, who makes sure that the plane can still fly? That's failover. Like you're part of, you have a cluster of multiple nodes and one node goes down. Who makes sure that the rest of the application can still process the minimum critical data needed for the application? Recovery is something has gone down, and now you are trying to make sure that it does, when it comes back online, there is like the transactions are not missing, duplicate, or if it's a banking app and you have missing and duplicate transaction, it's the end of the story. So that becomes critical in such situations and in many other situations. Idle is something you don't even put any load on the system. Just observe like what's happening on the system. Is it scaling down, or are there some zombie processes that are always consuming resources? Some tests that always bring some value. And the last one is chaos. So it's a mix of those. It's probably something that you should do at the end, like when you have achieved a lot of those scenarios that you want to achieve, like do some play around in the live environments. And there is some companies and there is some articles out there you can always read, like Netflix doing this and they made it popular. But it's again something for the future. But things don't happen if you don't have them in your plan. That's my point. And the last point that I want to share today is Measuring the measurement of success is the biggest motivator in any big project. So if you're measuring the success in the wrong way, then you are going to motivate the people and the project and the company in the wrong way. So I think what we should measure on is like how many aspects you have covered, meaning like are you sure that the endurance, stress, and the system is resilient, the system is performing, and many different things, not just 10,000 benchmarks that you have. And basically not the number of tests and the number of use cases that you have. So with that, that's it. I hope it was interesting, and I would be taking any questions if you have.